What really lies at the very edge of our solar system? Beyond the last ice giant, a vast unexplored territory awaits us. Mysterious objects defy the laws of physics. Frozen worlds roam in the dark, perhaps carrying the origins of life. And further still, other star systems lie in wait for us, their exoplanets glittering with a distant brilliance. Are they inhabited? Are they home to unknown civilizations? Dear traveler, welcome. Today we're embarking on an epic journey to the farthest reaches of our cosmic neighborhood. But before you set off on your next adventure, make sure you like the video and subscribe to the channel so you don't miss a thing. Thank you and have a great trip! Our magic ship has now left Earth, and you can already see it in the distance through the porthole. But in the distance, a red ball is already looming. It's our neighboring planet Mars. Research on Mars is in full swing. Numerous spacecraft have been sent into orbit around it, and others have already landed on its dusty surface. Let's leave the researchers to deepen their knowledge of Mars and continue our journey towards the first gaseous planet in our system, Jupiter. But between these two planets we'll cross the first asteroid belt. This belt is made up of billions of asteroids of all sizes. The largest is around 1,000 kilometers or 620 miles in diameter, while the smallest are the size of a pebble. These are rocky bodies of varying shapes. The largest are rather spherical, while the smallest are irregularly shaped. These rocks are composed of nickel, iron, or silicate. Researchers believe that it is Jupiter's gravitational force that prevents them from aggregating to form a planet. Our solar system is made up of 8 planets, equally divided between rocky and gaseous planets. The 4 rocky planets are located closest to the Sun, while the 4 gaseous planets are furthest away. Jupiter is the largest and most massive planet in the solar system. It completes 1 revolution around itself in just under 10 hours, and 1 revolution around the Sun in just under 12 Earth years. In passing, you can see that Jupiter is a tormented planet. Its thick atmosphere is home to swirling storms and many layers of clouds. If you look closely, you can see the Great Red Spot, a giant storm that scientists have been observing for centuries. But now we're approaching Saturn's rings. What a magical sight! Saturn is the second largest planet in the solar system. It too is a gas giant. Its atmosphere is also shaken by enormous storms. Don't get too close or you'll be shaken in all directions. It has 7 main rings composed mainly of grains of water ice ranging in size from a few micrometers to several meters. While you're enjoying this extraordinary view, our ship is rapidly approaching Uranus. 13 rings surround this pretty blue planet. It's methane that gives it its beautiful color. It also contains water and ammonia, of course in the form of ice. A unique feature of the solar system is that it appears to roll in its orbit. Its axis of rotation is practically in its plane of revolution around the Sun, which explains this phenomenon. But we're already approaching our first port of call, the planet Neptune, the starting point of our expedition. We have traveled 4.3 billion kilometers or 2.8 billion miles from Earth. Before us, the Voyager 2 probe completed this journey in just over 12 years, passing close to the planet on August 25, 1989. Fortunately, our spacecraft allows us to go much faster. Neptune is the last planet in the solar system and the furthest from the Sun. It orbits about 4.5 billion kilometers or 3 billion miles from the Sun. It was the first planet to be discovered by deduction rather than observation, since it is not visible to the naked eye. Several astronomers were looking for it, but it was Gall in 1846 who received the planet's position and discovered it by pointing his telescope at the indicated spot. It was the Voyager 2 flyby and the advent of the Hubble Space Telescope that gave us a better understanding of the planet. Its atmosphere is composed mainly of hydrogen and helium, with traces of hydrocarbons and volatile substances such as water, ammonia, and methane. The winds that blow over it are the best known in the solar system, as they are the fastest. They reach dizzying speeds of up to 2,100 kilometers per hour, or 1,300 miles per hour. As Neptune is the furthest planet from the Sun, temperatures at the top of its clouds are the coldest in the solar system, approaching -218 degrees Celsius or -360 degrees Fahrenheit. In 1930, astronomers discovered Pluto, which was considered a ninth planet until 2006, when it was reclassified as a dwarf planet. Neptune then once again became the solar system's most distant planet from the Sun. Neptune has 16 known natural satellites. Triton is the most massive, discovered just 17 days after its planet. With a diameter of just over 2,700 kilometers or 1,700 miles, it is the 7th largest natural satellite in the solar system. It's bigger than Pluto. Almost a century after Triton, Neptune's second satellite, Nereid, was discovered in 1949. This highly irregular moon has one of the most eccentric orbits in the solar system. Larissa was discovered in 1981 thanks to a star occultation. The other moons were discovered on Voyager 2 images, then in 2002 and 2003. In 1989, analysis of photos taken by Voyager 2 revealed Naiad, Thalassa, Despina, Galatea, and Proteus. In 2002, Halimede, Sao, Laoamide, and Niso were added to the list. In 2003, Psamathe was discovered. The last known moon to date was thought to be Hippocampus, discovered in 2013 by the Hubble telescope, but in February 2024, researchers were pleasantly surprised to discover 2 new moons. The first, S2021N1, is a retrograde irregular satellite that belongs to the same group as Psamathe and Niso. The second, S2002N5, belongs to the same group as Sao and Laoamide. Neptune's satellites can be divided into 2 groups: the regulars, which follow a circular prograde orbit in Neptune's equatorial plane; the irregulars, which follow an inclined eccentric orbit, generally retrograde, far from Neptune. Triton is an exception, as its orbit is circular and close to Neptune, but retrograde and inclined. As the latest discoveries show, this part of the universe has yet to be explored. It's sure to have some surprises in store for us. Let's continue our journey. Here is Pluto. It moves through the region known as the Kuiper Belt, which contains numerous celestial bodies. Long considered the 9th planet in the solar system, it was reclassified as a dwarf planet in 2006 because its size is smaller than that of some moons, and it has different characteristics from the other rocky objects that surround it. It is about 2/3 the size of our moon. It has a layered internal structure, like the telluric planets, but its density is lower. It has a rocky core surrounded by a mantle of ice. This mantle is made up of methane ice on one side and carbon monoxide ice on the other. It is 240 kilometers or 150 miles thick. Its core, with a diameter of around 880 kilometers or 550 miles, accounts for 60% of its mass. Pluto has a thin atmosphere that expands as it approaches the Sun and collapses as it moves away. This atmosphere is mainly composed of molecular nitrogen. Pluto orbits at around 7 billion kilometers or 4.3 billion miles, but due to its eccentricity, it is only 4 billion kilometers or 2.5 billion miles from the Sun when at perihelion. It then enters Neptune's orbit. Depending on its distance from the Sun, its temperature varies, but on average it's minus 228 degrees Celsius or minus 378 degrees Fahrenheit. Its revolution around the Sun lasts 248 years. The first probe to take a close look at Pluto was New Horizon, which visited the dwarf planet in 2015. The photos it took have enabled us to distinguish its surface more precisely and refine its size. Its diameter is 2,370 kilometers or 1,500 miles. Its surface features mountains, valleys, and depressions. The mountains, composed mainly of blocks of ice, rise to just 3 kilometers or 1.9 miles in height. In 2020, scientists confirmed the existence of cryovolcanoes, or ice volcanoes, on Pluto's surface. It is very likely that they are still active. Pluto was discovered on February 18, 1930, by amateur astronomer Clyde Tombaugh. Its first moon, Charon, was discovered only in 1978. In 2005, the satellites Nix and Hydra were discovered, followed by Kerberos in 2011 and Styx in 2012, thanks to the Hubble Space Telescope. This lunar system was probably formed as a result of a collision between Pluto and another body of the same size, early in the history of the solar system. Pluto and Charon are considered a double planet. It is the largest such system in our solar system. Charon is about half the size of Pluto. The Pluto-Charon pair has a special feature. Charon remains constantly above the same spot on Pluto's surface and always presents the same face to Pluto. Their rotation is synchronous. Another special feature is that their center of gravity lies outside Pluto. This is due to the ratio of the masses of the two bodies, which is quite high. Charon's mass is around 12% of Pluto's. Pluto's other moons are smaller, measuring less than 160 kilometers or 100 miles in diameter. They have an irregular shape. Hydra is 55 kilometers or 35 miles long. Nix is 42 kilometers or 26 miles long and bean-shaped. Observations indicate that they are covered in relatively pure water ice. Kerberos is Pluto's smallest known natural satellite. Its diameter is thought to be 13 kilometers or 8 miles. Its double-lobed shape is probably the result of the merger of two smaller objects. It orbits in 32 days, some 59,000 kilometers or 37,000 miles from Pluto, between Nix and Hydra. Styx is oblong in shape. It measures 7 kilometers or 4 miles in length. You can see why it was only recently discovered. It's tiny compared with the immensity that surrounds us. It was thought that this Plutonian system was formed by a massive collision, but this hypothesis is undermined by the fact that the bodies that make it up are not all the same color, and therefore would not have the same origin. Pluto and Nix are red, while the other bodies are more or less gray. The names of these satellites were chosen by the general public, with the constraint of giving names linked to the underworld, since in mythology Pluto is the master of the underworld, NASA's New Horizons probe has provided us with this new information on Pluto's satellites. It was the first space mission to explore this part of the solar system. The probe was launched in January 2006 and took advantage of Jupiter's gravitational assistance to reach Pluto. It began its observations in 2015, after 9 years of travel. It passed within 11,000 kilometers or 6,800 miles of Pluto on July 14, 2015, then within 27,000 kilometers or 16,800 miles of Charon. Pluto is one of the so-called trans-Neptunian objects. These are mainly icy dwarf planets with solid surfaces, composed mainly of frozen and rocky matter. They form the Kuiper Belt. Until 1990, no other celestial bodies had been discovered beyond the orbit of Pluto. In 1992, the first trans-Neptunian object was discovered, and then the discoveries multiplied. By 2006, when New Horizons was launched, over 1,000 more celestial bodies had been discovered. Observing the Plutonian system will give us new insights into celestial objects formed by giant impacts, bodies located at the edges of the solar system, and celestial bodies with atmospheres dominated by methane and nitrogen. Understanding Pluto will help us understand Titan and Triton. But where is the probe now? It's still traveling in the Kuiper Belt. The mission's objectives were due to be scaled back to the end of 2024, but many scientists rallied to have this date pushed back. They have succeeded, as NASA has granted them a further 4 to 5 years until the probe exits the Kuiper Belt. Researchers hope that the probe will come across other objects to study. Speaking of objects, let me tell you about a curiosity that New Horizons flew past on January 1, 2019. It's a funny rock called Eris. If you see it through the porthole, you'll recognize it straight away thanks to its special shape. It looks like a snowman, a big ball topped by a smaller one. But unlike a snowman, Eris is red. The object, first named 2014 MU69, was discovered in 2014 by the Hubble Space Telescope. Scientists were looking for an object to study in the Kuiper Belt and in the path of the New Horizons probe. In 2018, it was given the unofficial nickname Ultima Thule, and it was officially christened Eris in 2019. This means sky to the Powhatans, the people of Maryland where it was discovered. It orbits 6.5 billion kilometers or 4 billion miles from the Sun. It is the most distant celestial object ever visited by a space probe. On January 1, 2019, the probe passed within 3,500 kilometers or 2,200 miles of it. Observations before and during its flyby have enabled us to learn more about it. It is an elongated object measuring no more than 35 kilometers or 21 miles in length. Its rotation is very slow, taking 15.92 hours. Researchers believe that Eris was born of a very slow and therefore non-destructive collision 4 billion years ago. They believe that other objects in the Kuiper Belt were born in the same way. By studying the images taken by New Horizons, the researchers were able to get an idea of the landscape of this strange object. The two lobes are aligned, and the relief does not exceed 500 meters or 1,640 feet. Some 40 impact craters have been identified, making it possible to determine its age. Eris' surface is rich in frozen methanol. But why is it red? Scientists believe it's the interaction between light and frozen matter that gives it its color. To test this theory, they conducted a laboratory experiment. They simulated the effect of galactic cosmic rays on methanol ices under conditions of temperature and pressure identical to those experienced on Arrokoth. Ices exposed to radiation reproduce the color found on Arrokoth. But scientists have made other discoveries. There are sugars on its surface, notably ribose and glucose. Yes, you heard me right, the same one that runs in our blood. Surprising, isn't it? They also discovered allose, a sugar found in fruits and nuts. And there's more. They discovered glycerol, the humectant found in soaps, but also in sweets to improve texture and homogeneity. All these molecules are responsible for Arrokoth's red color. They are also necessary for the development of life. So we can now imagine that icy comets collided with the Earth and left us molecules like glucose. Life would then have developed on our planet. Scientists believe that other equally interesting objects are evolving in the Kuiper Belt and could reveal a great deal about the origins of the solar system and life on Earth. Since our ship is moving through the Kuiper Belt, let me tell you about it. It begins 4 billion kilometers or 2.5 billion miles from the Sun. It's 20 times wider and 20 to 200 times more massive than the asteroid belt found between Mars and Jupiter. Remember when we crossed it on our way here? The Kuiper Belt orbits the solar system. It contains most of the dwarf planets in this system, and above all, a great many asteroids. An asteroid is a celestial body made of rock and metal that orbits the Sun. Its size can vary from less than a centimeter to several hundred kilometers in diameter. Gerard Kuiper first mentioned the existence of the belt in 1951, but according to him it no longer existed. It would only have existed at the time of the formation of the solar system. Other scientists, on the other hand, believed it still existed. They proved this by finding other celestial bodies moving in Pluto's vicinity. Most of these bodies are asteroids, but there are also comets of all sizes. There are thought to be over 200 million icy bodies moving in the belt that could one day become comets. A comet is a small body composed of rock and ice. It is noticeable because it streaks across the sky, leaving a luminous trail behind it. As they approach the Sun, the ice they contain volatilizes. This sublimation forms a sort of tail of light. The origin of bodies traveling in the Kuiper Belt dates back to the formation of the solar system 4.6 billion years ago. In this respect, Kuiper was right. Large bodies were discovered, the dwarf planets. You've seen Pluto through the porthole, but let's go and meet Eris, Haumea, and Makemake. It's hard to spot the objects in the belt because they're so far away. That's why we only know a few of the larger ones. Some have been spotted but not yet classified, such as Ixion. It was discovered in 2001 by the Deep Ecliptic Survey Program. Its nature is not well known, with researchers hesitating as to whether it is a dwarf planet or an asteroid. Its size, estimated at 1,000 kilometers or 620 miles in diameter, was recently reassessed at 700 kilometers or 430 miles. Around 55 astronomical units from the Sun lies a zone known as the Kuiper Cliff. Here, the number of objects decreases sharply. This would be the outer limit of the Kuiper Belt. But let's stay in the Kuiper Belt a little longer. The objects found there are classified into 3 groups according to where they orbit. First are the TNOs, which are in 2 to 3 resonance with Neptune. They orbit the Sun twice while Neptune orbits 3 times. This means they cannot be gravitationally ejected by Neptune. Plutonos include, of course, Pluto, after whom they are named. There are also the companions I mentioned earlier: Charon, Nix, Hydra, Styx, and Kerberos. Ixion is here too, along with 1995 QY9, Lempo, Orcus, and 2017 OF69. But look, there's Orcus. Discovered in 2004, its distance from the Sun varies between 30 and 48 astronomical units. Its diameter is about 910 kilometers or 565 miles. Its orbit is quite similar to Pluto's, but with an opposite inclination to the ecliptic plane. Its orbital period is 245 years. Orcus is therefore currently close to its past aphelion in 2019, whereas Pluto was at its perihelion in 1989. It has been found to have a satellite called Vanth, 410 kilometers or 250 miles in diameter. It is too close to Orcus to determine its surface composition. Their names are rather sinister, since Orcus is the god of the underworld in Etruscan mythology, and Vanth the goddess of death. After several spectroscopic observations, researchers believe that Orcus's surface is covered with a mixture of water ice, ethane ice, ammonium ions, and tholins. Further inside the belt, we find the Kuiper, or classic Kuiper Belt objects. These objects remain at a great distance from Neptune and are not in major resonance with it. Like the planets, they have stable circular orbits. They are thought to have formed by slow accretion of matter from the protoplanetary disk. Kuiper are located in a disk formed by objects of resonance 2 to 3 to 1 to 2. Makemake, certainly the largest of these, measuring 1,430 kilometers or 900 miles in diameter. Discovered in 2005, it is now classified as a dwarf planet and is even the third largest of them. The dwarf planet Makemake orbits the Sun in 306 years. Researchers believe it is covered in ice, mainly methane. It has no atmosphere. It can be seen through an amateur telescope as it is very bright. You can find it in the constellation Bernice's Hare until 2027. Another Kuiper named Haumea is almost as big as Pluto, but its shape is closer to that of a rugby ball. This shape is certainly due to its very high rotation speed, around 4 hours. Haumea has 2 small satellites, Hyaka and Namaka. It takes an average of 285 years to circle the Sun. Its surface is quite bright, as it is mostly covered in water ice, with a few darker areas that are thought to be richer in minerals. In 2017, researchers discovered that it had a ring 70 kilometers or 40 miles wide, 2,290 kilometers or 1,430 miles from its surface. Another Kuiper is Albion, which was discovered in 1992. It was the first known member of the Kuiper Belt after Pluto and Charon, and the one that encouraged scientists to search for other objects in this zone. We now know hundreds of similar objects. Its surface is covered with carbon compounds, giving it a red color. Varuna was discovered in November 2000. Like Haumea, a rapid rotation speed gives it an elongated shape. Quaoar, at the time of its discovery in 2002, is one of the largest objects in the Kuiper Belt, with an estimated diameter of 1,100 kilometers or 680 miles. It has at least one satellite named Weywot. It orbits the Sun at an average distance of 43.5 astronomical units. It takes 286.6 years to complete a full circle, following an almost circular orbit. Quaoar is also known for its strange rings. Researchers have discovered 2 rings located beyond the Roche limit. At this distance from the main body, moving matter would have to accrete to form a satellite. And all this in just a few years. Laboratory studies have explained this disturbing phenomenon. Alternative collisions occur, preventing particles from agglomerating. 1998 WW31 is a double system of icy objects. The objects revolve around a common center of gravity. Logos is also a double object since its size is only slightly larger than that of its satellite Zoe. Zoe's diameter is 64 kilometers or 40 miles, while Logos's is just 80 kilometers or 50 miles. Zoe orbits only 8,000 kilometers or 5,000 miles from Logos. Teheran Hayawako is also accompanied by a satellite named Sawaskera. Terana Hayawako's diameter is 170 kilometers or 110 miles, while that of its satellite is 109 kilometers or 70 miles. Once again, we're talking about a double system. Bora Sisi, whose diameter measures 166 kilometers or 100 miles, is accompanied by the satellite Pabu, which has a diameter of 137 kilometers or 85 miles. As you can see, this is also a double system. The satellite orbits at 4,528 kilometers or 2,800 miles from its object. It was the Hubble Space Telescope that discovered most of these objects and provides us with information about them. Outside the part of the belt that includes the Cubewanos, we find a third group of objects, the TNOs. They are located in a less populated region. Their resonance is usually 1 to 2. They make half an orbit while Neptune makes 1. If you prefer, a TNO circles the Sun once while Neptune circles twice. Only the brightest TNOs have been identified and named. All these objects can be classified into 2 categories, the dynamically cold and the dynamically hot. The first has almost circular orbits, and these objects are predominantly red. It is thought to have formed roughly where it is today, although it may have been pushed outwards by Neptune during its migration. The dynamically hot population has more inclined orbits, up to 30 degrees on the ecliptic. It is thought to have formed near Jupiter and been ejected by the gas giants. Since 1992 and the discovery of the first Kuiper Belt object since Pluto and Charon, over 1,000 other objects have been discovered. The belt is thought to contain more than 70,000 bodies over 100 kilometers or 60 miles in diameter. No doubt some of these will be classified as dwarf planets in the future. But what are these stars made of? According to studies carried out on these objects, they are mainly composed of ice. These solid ices contain a mixture of light hydrocarbons such as methane, ammonia, and water ice. The mixture is identical to that of comets. The temperature of the belt is around minus 223 degrees Celsius or minus 369 degrees Fahrenheit, so the compounds are present in a solid state. The distance and small size of all these objects make them difficult to study. Current models are unable to explain the distribution of objects here, so there are still many unanswered questions. We are now counting on the future Pan-STARRS telescope to provide us with the elements we need to better understand the origin and complex structure of the Kuiper Belt. This telescope, located in Hawaii, will carry out astronomy and photometry of a large part of the sky almost continuously. The hope is to discover new celestial bodies by comparing the images. Scientists hope to discover at least 20,000 new objects in the Kuiper Belt. Let's now move away from the Kuiper Belt to observe objects that are no longer part of it, but most certainly originated from it. They are located in what is known as the disk of scattered objects. Let's start with Eris. After a first photograph in 2005, followed by several months of study, American researchers announced the discovery of a 10th planet in the solar system. Its name is a tribute to the Greek goddess of discord, since the discovery of this planet gave rise to much debate. It was after this discovery that eminent researchers got together to redefine the word planet. They clarified that a planet is a celestial body that has eliminated any body likely to move in a nearby orbit. Pluto and Eris, orbiting inside an asteroid belt, can therefore no longer belong to the group of planets. They are therefore downgraded to dwarf planets. They will be joined by Makemake, Haumea, and Eris. Trans-Neptunian dwarf planets are called planetoids when they have the same characteristics as Pluto. Eris, with a diameter of around 2,400 kilometers or 1,500 miles, is one of the largest known dwarf planets in the solar system. It is only slightly smaller than Pluto, but much more massive. It is the most massive of the trans-Neptunians. Its rotation period is 25 hours. Scientists believe it's very likely that Eris's surface is similar to Pluto's. It would therefore be a rocky dwarf planet. It is very bright, so it must be covered in ice. Researchers estimate that its surface temperature varies between minus 217 degrees Celsius and minus 243 degrees Celsius, or between minus 359 degrees Fahrenheit and minus 405 degrees Fahrenheit. Eris is so far from the Sun and so cold that its atmosphere freezes and collapses on its surface, forming a solid layer a few millimeters thick. This is the case right now, as Eris is so far from the Sun. Its atmosphere is in the form of snow. But it will begin to thaw as Eris approaches the Sun, and its atmosphere will reappear. Eris orbits the Sun in 558 years in an elliptical orbit. This explains why it is not always at the same distance from the Sun, and why its atmosphere freezes or thaws according to its proximity to the Sun. At its closest, Eris is 37.7 astronomical units from the Sun. That's 37.7 times the Earth's distance from the Sun. At its furthest point from the Sun, Eris is 97.6 astronomical units away. It's easy to see how such differences in distance can lead to differences in temperature. If you look closely, you'll see Dysnomia, the daughter of Eris in Greek mythology, but her satellite in space. Dysnomia is certainly the second largest moon of a dwarf planet, after Charon. Its diameter is estimated at around 615 kilometers or 380 miles. It takes 16 days to complete its orbit around Eris. Would you like to discover another trans-Neptunian object? Let me introduce you to Sedna, discovered in 2003. Its diameter is quite large at 1,500 kilometers or 930 miles. Its rotation period is around 10 hours. It is the non-cometary object with the longest period of revolution. It takes 11,486 years to go around the Sun. This is enormous. Only a handful of comets beat this record. It also has the highest aphelion in the solar system, 897 astronomical units. But it is currently approaching its perihelion, estimated at 76.3 astronomical units, which it should reach in 2076. Scientists believe that it is this distance that prevents its surface temperature from exceeding minus 240 degrees Celsius or minus 400 degrees Fahrenheit. So this is a very special object. It is also the reddest object in the solar system after Mars, although this color is common among trans-Neptunians. Its classification is not obvious, and not all researchers are of the same opinion. However, with a diameter of 1,000 kilometers or 620 miles, it is a good candidate for dwarf planet status. The Minor Planet Center considers Sedna to be a scattered object. These objects are placed in unusually elongated orbits by the influence of Neptune. Sedna's orbit is indeed very elongated, but the problem is that it has never been close enough to Neptune to be influenced by it. Sedna is not in the Kuiper Belt, but neither is it part of the distant Oort cloud. According to researcher David C. Jewett, Sedna and another object called 2000 CR105 are the tip of the iceberg in a new class of objects evolving between the Kuiper Belt and the Oort cloud. Sedna could not have formed in its present location. It would have formed either in the Kuiper Belt or in the region of the planets. It was probably a gravitational interaction that moved it out of Neptune's orbit. It is therefore difficult to give Sedna a status, as we lack the characteristics that would enable us to classify it. Sedna's distance makes it difficult to determine its shape. But we do know from spectroscopic measurements that its surface composition is similar to that of other trans-Neptunian objects. Can you guess what it's made of? Yes, a mixture of water ice, methane, and nitrogen with tholin. Tholin is a more or less nitrogenous organic substance with a high molecular weight and a rusty color. Its homogeneous color suggests that Sedna is rarely impacted by other bodies. Its structure is poorly understood. For the moment, no mission is planned to explore Sedna, but NASA has calculated that a flyby mission could take 24.48 years, using Jupiter's gravitational assistance and launching the probe between May 6th and June 23rd, 2046. That's quite precise for a project that is unlikely to materialize. Sedna will be closest to the Sun in 2075 to 2076. Maybe you'll hear more about her in the next few years. Keep your ears open. Other objects of the same type have been discovered by astronomer Chadwick Trujillo and his team. In March 2014, they announced the discovery of a potential dwarf planet, 2012 VP113. It could belong to the same category of objects as Sedna. Its diameter is 450 kilometers or 280 miles. Its closest point of orbit to the Sun is 12 billion kilometers or 8 billion miles away. It takes 4,220 years to complete its orbit. Its surface is assumed to be pink. The color is thought to be the result of chemical reactions produced by the radiation effect of frozen water, methane, and carbon dioxide. As 2012 VP113 has an elliptical orbit similar to that of Sedna, we can assume that there is an undiscovered planet that imposes this orbit on them. First detected in February 2016, 2015 RR245 is a trans-Neptunian object in resonance with Neptune. It averages over 8 billion kilometers or 5 billion miles from the Sun, 60 times farther than Earth. But this is only an average. It is currently 9.7 billion kilometers or 6 billion miles from the Sun, but can travel as far as 19 billion kilometers or 12 billion miles. At the moment, it's heading towards the Sun. It will reach its closest point in 2096, when it will be 5 billion kilometers or 3 billion miles from the Sun. It too has a highly elliptical orbit. It is in 2:9 resonance with Neptune. It therefore orbits twice while Neptune orbits 9 times. It is a potential dwarf planet with a diameter of around 600 kilometers, making it one of the 30 largest trans-Neptunian objects. So far at least, as you're well aware, new TNOs are being discovered on a regular basis. We've also discovered a satellite, but we don't have much information on it yet. 2015 RR245 remained at the outer edge of the Kuiper Belt when Uranus and Neptune suddenly pulled away from the Sun, chasing away the small bodies in their path. It was spotted by the Canada-France-Hawaii telescope, located on a volcano in Hawaii. Researchers from the OSOS program spotted a tiny point of light in a very distant orbit. OSOS stands for Outer Solar System Origin Survey. It can be translated as the Outer Solar System Origin Survey. The aim of this program is to find and track 1,000 trans-Neptunian objects. So far, I've shown you dwarf planets and icy objects that haven't yet been closely studied. But the space beyond Neptune also contains star systems, i.e., a small number of stars linked by gravitational attraction and orbiting each other. Have you ever heard of the famous star Sirius? This extremely luminous ball is the star Sirius. It's not the nearest star to our solar system, but it's the brightest star in the sky. Seen from Earth, it looks like it's blinking. It's not actually blinking, but it's very low on the horizon, and the light it emits has to travel a long way through the atmosphere to reach us. Turbulence in the atmosphere deflects the light rays, producing the blinking effect. But why does it shine so brightly? Simply because it's 25 times brighter than the Sun and only 8.6 light-years from Earth. That's the equivalent of 82 billion kilometers or 51 billion miles. But in astronomical terms, this is not an extraordinary distance. The light it emits therefore takes more than 8 years to reach us. Our Sun sends out its light in just 8 minutes. For observers in the northern hemisphere, Sirius lies low in the sky, so its light passes through a thick layer of air. The turbulence I mentioned earlier acts like refracting prisms, splitting Sirius's white light and randomly reflecting different colors back to our eyes. These colors are actually wavelengths. Sirius will shine brighter and brighter as it moves towards us. It is one of the most studied stars by astronomers. The Egyptians associated it with the flooding of the Nile, the Chinese with a wolf, and the Greeks with a dog. What do we know about this star of the sky? Sirius is a white dwarf. It is also a binary star, since a white star has been discovered to accompany it, Sirius B. A binary star is a system made up of 2 stars revolving around the same point. The surface temperature of Sirius is 9,626 degrees Celsius, or 17,360 degrees Fahrenheit. It is therefore much hotter than the Sun, whose surface is 5,504 degrees Celsius, or 10,000 degrees Fahrenheit. But it's also much brighter, 2.3 times more massive and 1.8 times larger than the Sun. Impressive, isn't it? Its age is estimated at between 237 and 247 million years. Sirius is a white star. In a photo taken by the Hubble telescope, it is slightly blue. Yet its color has been the talk of the town. In ancient times, it was described as sometimes red, sometimes white. It takes millions of years for a star to change color. Far too long for humans to observe the change, and it can only go from white to red, not the other way around. In 1995, astronomer Ceragioli proposed explanations for these contradictory observations. When Sirius is at its lowest point on the horizon, it can appear reddish. This is because light has to travel a very long distance, and when it arrives, only warm colors like red have managed to pass through the atmosphere. The others were partially absorbed. Ceragioli also believes there are transition explanations, since in some languages the same word is used for red and bright. From the northern hemisphere, Sirius is never very high on the horizon. It's easy to spot because it's bright, but also because it's in direct alignment with the three stars of Orion's shoulder belt. Sirius has a strong momentum of its own, due to its relative proximity to the Sun. Its position on the celestial sphere varies more rapidly over time than that of other stars. Its chemical composition is 3 times more abundant in iron than that of the Sun. Let's talk a little about its companion, Sirius B. This white dwarf orbits with a period of 50 years. It was the first white dwarf to be discovered in 1862. It is one of the 3 best-known white dwarfs, along with Procyon b and 40 Eridani b. A white dwarf is an incredibly dense star, no more than 1.44 times the mass of the Sun. A value of a ton per cubic centimeter has been suggested for Sirius B. Imagine the astonishment of astrophysicists in the early 20th century. A white dwarf is the residue of a modest star, no larger than 8 solar masses, which has exhausted its nuclear fuel and ejected its upper layers in the form of a planetary nebula. It's pretty much inert, except when it's part of a binary system, as is the case with Sirius. In this case, there comes a time when it tears gas from its neighbor. An accretion disk forms, and gas falls onto the white dwarf, which then expands until it reaches what is known as the Chandrasekhar limit. At this point, the white dwarf is blown up by an explosion. This is the origin of at least some of the supernovae we call SNs. Here's what we know about the future of this binary system. For the moment, the orbit of the Sirius A-Sirius B system is highly elliptical. The distance between the 2 stars varies between 8.1 and 31.5 astronomical units. The diameter of Sirius B is comparable to that of the Earth. Sirius B is much smaller than Sirius A, but 3 times hotter. This bright star has long inspired artists. I told you about Tintin, but Sirius appeared as early as 1752 in Voltaire's Micromegas. The main character is a Sirian, just like the V-series visitors from a planet orbiting Sirius. Given the temperature on Sirius, we're not likely to meet any Sirians, but there's nothing to stop us imagining them. Let's retrace our steps a little to approach another star system, Alpha Centauri. It lies 4 light-years from the Sun in the constellation Centauri. It's the closest star system to the Sun. Together with the stars Alpha Centauri A and Alpha Centauri B, they form the Alpha Centauri system. This is a triple star system. The system's main body is Proxima Centauri, as it is the star closest to Earth after the Sun. It's a red dwarf, a category of low-mass faint stars that are widespread in the Milky Way galaxy. With an apparent magnitude of 11.05, it is 20,000 times less luminous than the Sun and 8 times less massive. It was only discovered in 1915, since a telescope is needed to observe it. Its diameter has only been known since 2002. It was measured using the interferometer of the Very Large Telescope. With a diameter of 200,000 kilometers or 125,000 miles, Proxima Centauri is 7 times smaller than the Sun. It is also a variable star, as its luminosity varies over time. Its powerful magnetic field is at the origin of gigantic stellar eruptions that significantly increase its luminosity. At least one planet has been found orbiting Proxima Centauri, Proxima Centauri b. This is an exoplanet, probably telluric, with a minimum mass of 1.3 Earth masses. It is the closest exoplanet detected to date. It was discovered only recently in August 2016. It lies in the star's habitable zone. This is the zone around the star where it is neither too hot nor too cold for water to remain in a liquid state on a planet's surface. Its temperature is estimated at -40 degrees Celsius or -40 degrees Fahrenheit. It orbits about 7 million kilometers or 4.3 million miles from Proxima Centauri. But Proxima Centauri b is too close to the red dwarf, so there could be no life on it. Red dwarfs are very active indeed. Huge volcanic eruptions emit highly energetic X-rays and ultraviolet rays, but are hardly conducive to the development of life. Proxima Centauri b completes its rotation around its star in 11 days, which tells you how close it is. Close enough to be exposed to the star's violent puffs. These findings call into question the habitability of all planets orbiting red dwarfs, at least until the next exception. In 2017, researchers announced the discovery of at least one dust belt around Proxima Centauri, but there could be 2 or even 3. This belt would have a temperature of -230 degrees Celsius or -382 degrees Fahrenheit, comparable to that of the Kuiper Belt. It includes dust and objects up to 50 kilometers or 30 miles in size. Its total mass is estimated at around 0.01 times that of the Earth. Does Proxima Centauri have any other companions? The first could be a super-Earth whose period of revolution around Proxima Centauri would be greater than that of Proxima Centauri b. Its orbital period would be around 1900 days or just over 5 years. Called Proxima Centauri c, this exoplanet would be 6 times the mass of the Earth. Its existence has yet to be proven. If it does exist, it would call into question models of planet formation. Researchers are counting on the help of the Gaia satellite to combine various astrometric measurements with the star's radial velocity to provide answers. The radial velocity technique will certainly enable scientists to discover new planets. There is also some doubt about its luminosity. The object shown in an image is very bright. To be so bright, it would have to be too big to be a planet. Researchers think it could be surrounded by a system of ice rings or a cloud cover that would allow it to reflect light. But that's not all. In 2022, a team from the Southern Observatory detected the existence of another planet, named Proxima Centauri d, using the Very Large Telescope. This low-mass planet has a mass equivalent to a quarter that of Earth. It orbits Proxima Centauri in just 5 days at a distance of 4 million kilometers or 2.5 million miles. Proxima Centauri is expected to remain on its main sequence for at least 4,000 billion years. It will get smaller and hotter as the proportion of helium in it increases due to hydrogen fusion. It will become brighter, heating up its planetary system for billions of years. When all the hydrogen is used up, it will evolve into a white dwarf. Proxima Centauri orbits the double star Alpha Centauri, with a period of around 547,000 years. It is currently near the furthest point of its orbit. Let's turn now to Alpha Centauri A and B, the other two stars in this system. They form a double star that closely resembles the Sun. Alpha Centauri A is slightly more massive than its neighbor. The distance between them varies from 1.5 to 5 billion kilometers, and they revolve around a common virtual center in around 80 years. It takes a very powerful telescope such as Hubble to distinguish them. Alpha Centauri A is the brightest of the three stars in the Alpha Centauri system, and the fourth brightest in our night sky. Alpha Centauri A has characteristics close to those of the Sun. Like the Sun, it is a yellow dwarf star in the main sequence. More precisely, it is a G2V spectral type star. In astronomy, the spectral type of a star is determined by four characteristics: color temperature, surface gravity, mass, and luminosity. The abundance of chemical elements in its composition is twice that of the Sun. It is 10% more massive than the Sun, and its radius is 23% greater. We don't know much more about this star, but one event is already on the researchers' agenda. This is a gravitational microlensing event that will occur when Alpha Centauri A passes in front of the supergiant star S5. This will happen in May 2028 and should lead to the discovery of possible planets orbiting Alpha Centauri A. Right next door, you'll see Alpha Centauri B. It's an orange dwarf this time, so we have three dwarf stars but of different colors. As a reminder, an orange dwarf is a star whose luminosity lies between that of a yellow dwarf and a red dwarf. This seems logical enough. They are smaller, cooler, and less luminous than the Sun, which is a yellow dwarf. Alpha Centauri B belongs to the main sequence and is of spectral type K1V. Its mass is around 90% that of the Sun. In October 2012, the discovery of a planet, Alpha Centauri BB, was announced. It is said to be comparable in size to Earth and to be traveling 6 million kilometers from its star. It would complete its orbit in 3.2 days. But once again, we have no certainty, as several studies have called this discovery into question. In 2013, another exoplanet may have been detected, following the observation of a transit-like event. For the moment, the existence of this planet has not been confirmed either. This star system is the closest to our own, but it's still a long way away. To get more information, we'd have to send a space probe there. But even the fastest probe would take tens of thousands of years to reach its destination. Voyager 1, which has already been away for over 40 years, would take another 76,000 years to reach Alpha Centauri. In 2016, a rather crazy project was announced, with the participation of the famous astrophysicist Stephen Hawking, who has since passed away. The project, called Breakthrough Starshot, aims to launch tiny probes weighing just 1 gram into space. They would be propelled by laser beams that would strike tiny sails to give them speed. This technique would enable them to reach speeds of 60,000 kilometers per second, or 37,000 miles per second. At this speed, the probe would reach Alpha Centauri in just 20 years, and the Moon in 7 seconds. The problem lies in the difficulty these probes would have in sending information back to us. They wouldn't be able to carry any material, and the return journey would take 4 years at the speed of light. Before heading back to Earth, let's take a look back at our solar system. There, in November 2018, American astronomers discovered a dwarf planet they called Far Out. This planet is located far out there indeed, more than 18 billion kilometers or 18 billion miles from the Sun, or 120 astronomical units if you prefer. So it's well beyond the orbit of Pluto and even Eris. Its surface, on the other hand, resembles Pluto's. Ice is of water, nitrogen, carbon dioxide, and organic substances reddened by the faint glow of the Sun. It was discovered by chance as astronomers scanned the skies for the mysterious Planet X. Also known as 2018 VG18, Far Out takes 1,000 years to complete its orbit around the Sun. It is currently known to have a diameter of 500 kilometers or 310 miles, to be composed mainly of ice and to be pink in color. Its orbit will be difficult to determine, as Far Out moves much more slowly than any other object in the solar system. Just a few months after its discovery, another object was observed even further away from us, unofficially nicknamed Far Far Out. It is currently 132 astronomical units from the Sun, or around 20 billion kilometers or 12 billion miles. Its orbit is known to be quite elongated, and it too takes 1,000 years to go around it. It enters Neptune's orbit when it is closest to the Sun. Neptune's orbit is 30 astronomical units away, and Far Far Out passes within 27 astronomical units of the Sun. But when Far Far Out is farthest from the Sun, its path passes within 175 astronomical units of the Sun. According to the researchers, these orbital dynamics can help us understand how Neptune formed and evolved. Neptune's diameter is estimated at 400 kilometers or 250 miles, placing it at the lower end of the scale of objects that could qualify as dwarf planets. The same team of researchers had already spotted another trans-Neptunian object in 2015. Called the Goblin because it was discovered on Halloween, it was finally renamed Haumea in 2020. Its diameter is difficult to estimate. It takes around 32,000 years to circle the Sun, and its elliptical orbit can take it as far as 2,000 astronomical units from the Sun. This slowness has enabled researchers to observe it closely for 3 years. Researchers still searching for the 9th planet, or Planet X, believe that the Goblin's peculiar course indicates the influence of a massive body that could be this mysterious 9th planet. But where is it hiding? Some believe it lies in the Oort cloud and could be 10 times more massive than our Earth. But is it transparent? Researchers think it's very dark. This darkness, combined with its distance, would make it almost invisible. Before it was discovered, Pluto's suspected existence was also known as Planet X. X represents the unknown in mathematics. Until it is discovered, this hypothetical planet is the talk of the town among scientists. They believe that other objects, such as the Goblin or Far Out, exist at the farthest reaches of the solar system. It's hard to say how many. On the way back, you'll be lucky enough to spot a few more objects, such as 2007 OR10, which you can see through the porthole. Also known as Gong Gong, this is one of the scattered objects. It was discovered in 2007, but American astronomers only confirmed its existence in 2009. Its highly inclined eccentric orbit takes it from 34 to 101 astronomical units. It completes this orbit in 554 years. Its orbital resonance with Neptune is 3 to 10. While Neptune makes 10 revolutions around the Sun, it only makes 3. Gong Gong can be considered a dwarf planet with a diameter of 1,230 kilometers or 760 miles, about the same size as Charon. Its surface contains tholins, making it red in color. The presence of tholins on its surface implies the possible existence of a tenuous methane atmosphere. Water ice is also found on its surface, suggesting that in the past it experienced a brief period of cryovolcanic activity. It rotates slowly compared with other trans-Neptunian objects with a rotation period of around 22 hours, compared with less than 12 for most other objects of the same type. This slow rotation, caused by its tidal forces, could be explained by its natural satellite, discovered in 2016. Called Qiangliu and discovered by the Hubble telescope, its diameter is around 300 kilometers or 190 miles. It orbits about 24,000 kilometers or 15,000 miles from Gong Gong. Its orbital period is 25 days. Just 30 years ago, we knew of only 2 objects orbiting in the geographical area we've just crossed beyond Neptune. As scientific means of studying space evolve, so does our knowledge of it. You've seen that the farthest reaches of our solar system are home to all kinds of objects, some of them very strange. We've crossed paths with dwarf planets, asteroids, and scattered objects, and gone even further to double and even triple star systems. What else will we discover? The flagship program brings together a number of space exploration missions launched by NASA to explore the solar system. These missions are very expensive and focus on priority targets that are difficult to explore. One of the program's objectives is to explore the deep layers of Neptune's atmosphere and the surface of its moon Triton. The Trident project, part of NASA's Discovery program, is scheduled to carry out a unique flyby of Triton and Neptune in 2038. This is a difficult objective to achieve given the distance involved. It's also very expensive. Scientists have looked for and found ways to reduce the bill so that the project can be accepted. The Trident mission is due to be launched on October 25, 2025, by a rocket that will take advantage of a launch window corresponding to a planetary configuration that occurs very rarely. This will enable it to reach its destination, 29 astronomical units from Earth, without the need for propulsion. The probe will use the famous gravitational assist technique, tested and approved by the Voyager 1 and 2 probes over 40 years ago. Specific dates have already been set. Trident will rendezvous with Venus on March 25, 2027, then Earth on February 7, 2031. The flyby of Triton is scheduled for June 28, 2038. The probe should pass within 500 kilometers of the satellite before flying over Neptune a few hours later. Let's make a date for the same trip in 20 years' time. I'm sure it will be very different. So soon? From here, we arrive in a zone close to the Earth and our solar system. The solar system is home, among other things, to the Earth, our planet. The Sun is the closest star to us, which is why it seems gigantic compared to the others. and yet it is similar to the other thousands of stars we can see, shining in the night sky. Apart from the Sun, the planets are the largest objects in the solar system. There are 8 of them, grouped into 3 distinct families: telluric planets and giant planets. The first category includes Earth, Mercury, Venus, and Mars. The terrestrial planets are closest to the Sun. They are modest in size, have atmospheres, except Mercury, and are rocky. The giant planets include Jupiter, Saturn, Uranus, and Neptune. They are large and composed mainly of gas. Most planets have 1 or more moons, which are natural satellites. Each of the 4 giant planets has numerous moons orbiting it, as if it were a model solar system. Jupiter, for example, has 92 known moons, including Ganymede, one of the largest. Giant planets are also characterized by the presence of rings. The best known are Saturn's rings. They are composed of small particles of dust and ice, as well as rocky fragments. Messier 42, also known as the Orion Nebula, is the closest diffuse nebula to Earth. This cloud of gas and dust is a veritable nursery of stars, which, given their proximity, have been detected by astronomers. Like other diffuse nebulae, the Orion Nebula glows thanks to a phenomenon known as fluorescence. The gas atoms are excited by the ultraviolet radiation of the bright star, causing them to produce light as well. The color emitted depends on the type of atoms. In nebulae, the majority of atoms are hydrogen, which emits red light. Sulfur also emits the same color. Oxygen shines in green. Unfortunately, at night, our eyes can't distinguish between the colors, so they appear mostly gray to us. But the Orion Nebula is an exception to this rule, thanks to its high contrast. Messier 42 is easy to observe through binoculars. It appears like a small cloud among the stars of Orion's sword. Through a telescope, green can be seen in its central region. This hue is confirmed with a more powerful telescope. Hydrogen atoms are far more abundant than oxygen atoms in the Orion Nebula. The nebula measures around 24 light-years. It is, in fact, only the main part of an even larger cloud of gas and dust, called the Orion Cloud. At the heart of the Orion Nebula lies a huge bubble of gas reaching a temperature of 2 million degrees Celsius, or 3.6 million degrees Fahrenheit. The North American Nebula, also known as NGC 7000 or the American Nebula, is located in the constellation Cygnus, some 1,890 light-years away. Its name derives from its shape, which evokes the silhouette of North America. It lies next to another nebula known as the Pelican. Together, they form the visible part of an immense hydrogen cloud. The mass of gas in these 2 nebulae is thought to be around 5,000 solar masses. Astronomers believe that the energy required for the nebulae to fluoresce is provided by the nearby supergiant star Deneb. Although there are other nebulae in the Milky Way that are at least as large, the American Nebula is one of the only ones visible to the naked eye. It can be seen under excellent observation conditions. It emits the same light as a magnitude 5 star, but over such a large area that it's harder to spot. Simply spot the bright star Deneb, and the shape of the American continent will appear right next to it. The America Nebula and the Pelican Nebula each measure around 50 light-years in diameter. They are separated from each other by absorption clouds. Close to the North American Nebula is the star Alpha Cygni. More commonly known as Deneb, Alpha Cygni is a variable white supergiant star. It is the brightest star in the Cygnus constellation, and the 19th brightest star in the sky. Its magnitude is 1.25. Its surface temperature reaches 8,400 degrees Celsius, or 15,000 degrees Fahrenheit. Its mass is around 20 solar masses. Alpha Deu Cygni's stellar wind causes it to lose 0.8 millionths of a solar mass each year. Together with Vega and Altair, Deneb forms the Summer Triangle. It is one of the great landmarks of the summer sky. This grouping of stars forms an obvious pattern without belonging to a single constellation. It's an asterism. Deneb belongs to the constellation Cygnus, Vega to Lyra, and Altair to Eagle. Although Deneb is the furthest away from us, it remains as visible to the naked eye as the other two, thanks to its extreme brightness. Also known as the Vela pulsar, this young pulsar is located in the constellation Vela, some 959 light-years from Earth. The Vela pulsar was the first young pulsar discovered, along with the Crab pulsar in 1968, by astronomers from the University of Sydney. We'll talk more about the Crab pulsar later, which lies further out on the edge of the Milky Way. The word pulsar is short for pulsating star. The main characteristic of these objects is that they emit radiation in the form of regular radio pulses that are extremely fast. A single pulse can range from tens of milliseconds to tens or hundreds of seconds at most. The shape of a pulse and its period vary from one pulsar to another, but they remain relatively constant for each one. Variations can only be detected over long periods. Pulsars are veritable cosmic chronometers, thanks to the regularity of their pulsation. Although older than the Crab pulsar, the Sail pulsar is defined by its still very low rotation period. It is, however, characterized by its impressive number of glitches, which are abrupt variations in the rotation period, following a slowdown in the pulsar's rotation. The Vela pulsar is the central energy source of a region known as Vela XYZ. This supernova afterglow is home to numerous pulsars. It is one of the brightest afterglows in the radio range. The planetary nebula NGC 7293, also known as the Helix Nebula, is located in the constellation Aquarius. Its shape has often been compared to that of a human eye, giving it the nickname the Eye of God. It is one of the closest planetary nebulae to Earth. It is also one of the most closely observed by astronomy enthusiasts. Located 650 light-years from Earth, it appears as two intertwined rings. The white dwarf at the center is surrounded by a disk of red dust, making all the surrounding gas fluoresce. The nebula extends over a diameter of 5.74 light-years. Astronomers believe it began to expand around 12,000 years ago. At that time, a reddish star visible to the naked eye, increased in brightness before disappearing. Since then, in its place, the nebula has spread its corolla wider and wider, but fainter and fainter. The colors are linked to the type of atoms ejected by the star at the end of its life. Red corresponds to hydrogen, blue and green to oxygen, and yellow to nitrogen. These elements spread out into space, enriching the composition of the surrounding atmosphere. Because of its proximity to Earth, the Helix Nebula offers us a wealth of detail. Objects resembling comet tails have been photographed in impressive numbers, with over 20,000 nestling within the nebula. They are thought to be the result of collisions between zones of gas at different temperatures. From Earth, through binoculars, NGC 7293 appears as a gray disk in a perfect sky. NGC 3324 is an emission nebula located to the north of NGC 3372, also known as the Carina Nebula. Located in a chaotic gas and dust-rich region of the Carina Nebula, NGC 3324 saw the formation of many hot, massive stars several million years ago. The radiation and stellar winds of these young stars expel matter from the nebula, forming a hollow within it. The expelled matter forms an illuminated zone, known as the face of a famous Chilean poetess, Gabriela Mistral. The Carina Nebula, NGC 3372, is one of the brightest and largest nebulae known. It extends over more than 300 light-years. It contains numerous supergiant stars, the brightest and most massive of which is Eta de la Carine. Eta de la Carine proudly boasts a mass 120 times greater than the Sun, and a luminosity 4 million times greater. Today, its magnitude is 4.5, making it faintly visible to the naked eye. In the past, however, it underwent a gigantic eruption that made it the second brightest star, just behind Sirius. This event generated a strong eruption of matter. Weaker eruptions continue to this day. One day, Eta de la Carine, which remains highly unstable, will explode in an extraordinary supernova. From Earth, the Carina Nebula is easy to observe from the Tropic of Cancer, in the West Indies, for example. To the naked eye, it displays its magnitude 1 as a beautiful gray cloud. With binoculars, this cloud becomes more complex in two parts. The star, Eta de la Carine, on the other hand, appears orange without any instruments. Within the Carina Nebula is a peculiar object known as the Keyhole Nebula. This is a small dark cloud of cold molecules and dust that also contains bright filaments of hot fluorescent gas. The diameter of this structure is around 7 light-years. In the Southern Cross constellation lies NGC 4755, known as the Kappa Crucis cluster, also nicknamed the Jewel Box. This young open cluster is located around 6,440 light-years from the solar system. Its apparent size is around 19 light-years, and its age is estimated at 16.4 million years. The name Jewel Box is due to the magnificent multicolored sparkles of its gem-like stars. In the center of the cluster, bright stars form an A-shaped asterism. The tip is marked by HD 111904, a variable supergiant. It has a magnitude of 5.77. The bar of the A is formed by 4 aligned stars with magnitudes of 6.92, 8.66, 7.1, and 7.6 respectively. Finally, the 2 legs of the A are marked by 2 blue supergiant stars. Located in the Scorpio constellation, Antares, also known as Alpha Scorpii, is a double star whose main component is a red supergiant at the end of its life, called Antares A. Its volume is 680 million times greater than that of the Sun. To better represent its immensity, if its size were reduced to that of the solar system, it would encompass the orbit of Mars. Antares' magnitude ranges from 0.9 to 1.8. It is some 10,000 times brighter than the Sun, yet its surface temperature is lower, at around 3,600 degrees Celsius or 6,500 degrees Fahrenheit, compared with 5,500 degrees Celsius or 9,900 degrees Fahrenheit for the Sun. In the near future, Antares will explode as a supernova, shining brightly across the sky for several weeks. The supergiant's companion is called Antares B. It is a dwarf star with a magnitude of 5.5. It's much less bright than Antares A, but it's still 170 times brighter than the Sun. Antares B is difficult to observe, given its brightness and proximity to Antares A. But with a good instrument, Antares B appears green. This is a contrast effect. Not far from Antares are 2 clusters. M4 is the closest to Antares, and also the closest to us. It is a globular cluster, but not the most spectacular. M7 is further away. It's an open cluster located near the tail of Scorpio. It is visible to the naked eye from Earth. M7 is also known as the Ptolemy cluster. It is an open cluster in the constellation Scorpius. It lies around 903 light-years from the solar system, and is thought to be around 140 million years old. In good observational conditions, the cluster is visible to the naked eye from Earth. If you use binoculars or a telescope, the stars will appear. Clusters are areas in the sky where the stars are denser than is generally the case. In some cases, the density is quite obvious, but in others it's less so. As a result, clusters are harder to separate from the surrounding stars. To determine whether stars belong to the same cluster, astronomers study their motion and measure their distance from the Earth. Stars belonging to the same cluster move in the same direction. What's more, if stars that look close together are at the same distance from the solar system, it's possible that they're connected by the force of gravity. In this way, they form an open cluster. Open clusters vary in size from around 6 to over 30 light-years, with an average dimension of around 10 light-years. Stars are arranged in variable patterns, without representing any particular shape. They are classified according to their concentration, total number, luminosity difference, and angular dimensions, which depend on the actual size of the cluster, or its distance from the Earth. Whatever their class, all stars belonging to the same open cluster remain homogeneous. As they are all formed from the same gas nebula, they all have the same original chemical composition. Astronomers also suggest that they were born at the same time, and therefore have the same age. Stars are bound together by the force of gravity, but as this bond is not very strong, open clusters slowly dissociate. Most open clusters are made up of young stars and are deployed in the spiral arms of the Milky Way. Messier 4 is the closest globular cluster to us. A globular cluster is a concentration of several 100,000 stars within a small radius of a few tens of light years. Today, 150 globular clusters are known in a vast halo around our galaxy. M4 is the closest of all, at 7,200 light-years from Earth. It has a low concentration of stars, with just 70,000 scattered around a sphere 75 light-years in diameter. According to its metallicity, M4 is around 12.54 billion years old. The iron concentration of clusters in the Milky Way halo varies from 1/100th to 1/10th of the iron concentration of the Sun. This gives rise to two subgroups: relatively young clusters and old clusters. Messier 4 belongs to the former category. M4 stands in the celestial vault west of the red giant Antares. Through binoculars, it appears as a diffuse, colorless ball. Through a telescope, this homogeneously bright cluster reveals numerous stars. In 2003, astronomers made an incredible discovery in M4 using the Hubble Space Telescope. It was an exoplanet called PSR B1620-26b. It orbits a white dwarf and a pulsar. It is thought to have a mass 2.5 times that of Jupiter, and to be around 13 billion years old. This exoplanet could have formed at the edge of the globular cluster, at the same time as the other M4 stars. In diffuse nebulae, clouds of dark dust mix with gas to form familiar shapes. This is how a lagoon is sculpted in the Messier 8 nebula and a clover in the Messier 20 nebula. The lagoon and Trifid nebula offer a magnificent spectacle and are very fertile. Astronomers have discovered young stars in their embryonic stages. Both nebulae are located at the same distance from Earth and are certainly only a tiny part of a gigantic cloud of gas and dust. The Lagoon Nebula can be seen with the naked eye at night in good viewing conditions. It appears as a diffuse spot. It forms a lovely duo with the Trifid Nebula a little further north, which appears as a diffuse veil around two stars. Let's take a closer look. The Trifid Nebula, or Messier 20, lies in the constellation Sagittarius, in a star-forming region in the Centaur arm of the Milky Way. Within the nebula is an open cluster of stars called NGC 6514. M20's three-lobed arrangement has given it the name Clover Nebula. The nebula contains some 3,100 stars known to date. Around 30 of these are massive embryonic stars, while 120 newly formed stars are scattered in both dark corridors and luminous clouds. The Trifid Nebula is known as an emission nebula, with a dark nebula passing through it, giving it its distinctive appearance. In the starry sky, it appears as a bright luminous disk with a second disk of more or less the same size, but less bright. At the center of each disk is a star, one of which is a triple star. The Trifid Nebula is located in a particularly rich area of the sky, sharing the limelight with Messier 8's Lagoon Nebula. Messier 8, also known as the Lagoon Nebula, is located in Sagittarius. It is a diffuse nebula within which many young stars are born. This immense cloud of hydrogen and dust contains a star that illuminates it, 9 Sagittarii. This binary system of 2 blue giants has an orbital period of 9.1 years. The distance between each star varies between 11 and 27 astronomical units. The star appears to be 1,250 parsecs from the nebula. M8 is about 4,100 light-years from Earth. It contains a magnificent open cluster, NGC 6530, with young hot stars only 2 million years old. The cluster is thought to contain between 50 and 100 stars of average concentration, with magnitudes spread over a medium range. The Lagoon Nebula is easily detected by the naked eye in ideal observing conditions, thanks to its magnitude of 6. Messier 57, also known as the Lyra Nebula, is known as the most representative of planetary nebulae. They're called planetary nebulae because early observers mistook them for planets, given their circular shape. In reality, they are formed by the emission of an envelope of gas from stars at an advanced stage of evolution. They are like the magnificent crowns that surround stars of similar size to the Sun as they fade away. At the center of planetary nebulae, the star's core will continue to shine for some time, illuminating the gas around it. It's called a white dwarf because of its small size and high heat content. At the heart of the Lyra Nebula, its temperature reaches 100,000 degrees Celsius, or 180,000 degrees Fahrenheit. M57 is not easily identifiable with the naked eye, due to its low surface brightness and magnitude 8.8. It is, however, easy to locate. Just look for the summer triangle made up of Altair, Deneb, and Vega. Messier 57 then lies between the stars Beta and Gamma Lyrae. The inner parts of the nebula have a blue-green hue, while the outer region of the ring has a reddish tinge. Its three-dimensional shape is not easy to extrapolate. It could be very elongated and bipolar in nature. Long-lapse photographs reveal extensions far more extensive than the main ring, which are thought to be the result of matter ejections by the star that took place long before the nebula itself was formed. In the Altair constellation, we find the second closest globular cluster to Earth. NGC 6397, also known as Caldwell 86, contains almost 400,000 stars. It lies 19,550 light-years from the center of the Milky Way. Caldwell 86 is an old globular cluster, relatively low in heavy metals. The cluster contains several types of star: white dwarfs, low-mass stars, red giants, variable stars, and blue stragglers. Two categories of white dwarfs are present in the cluster: those composed mainly of carbon and oxygen, and those composed mainly of helium. The latter are formed when the parent star has been subjected to matter exchange in a stellar system. There are also two types of red giant in NGC 6397. One type was formed in the early days of the cluster's formation, and is therefore low in heavy metals. The other type was formed from materials produced by hydrogen fusion. The stars are therefore richer in heavy metals, and were born much later. Caldwell 86 also contains numerous variable stars. Their metallicity is low, and their period varies from 0.004 to 2 days. Also in this category are cataclysmic variables. These are a type of binary star composed of a white primary and a companion that transfers its mass to it. For this mass transfer to last the lifetime of the star system, the companion must fill its lobe with rock. This is a teardrop-shaped lobe in which matter is contained and which is gravitationally bound to the star. Finally, a few blue stragglers have been identified. Their surface temperatures are close to 10,000 degrees Celsius, or 18,000 degrees Fahrenheit. In 2020, 2 astronomers wondered about the possible presence of an intermediate black hole. It could be that an invisible component remains at the heart of Caldwell 86, with a mass of between 1,000 and 2,000 solar masses. These same astronomers have also developed a hypothesis concerning the presence of some 60 stellar black holes hidden in the center of the globular cluster. Indeed, the cluster's center contains invisible matter. The small size of this matter suggests that it may be the remnants of massive stars that have slowly migrated towards the center. Located 5,500 light-years from Earth, Messier 17, also known as the Omega Nebula or the Swan Nebula, is an emission nebula containing a young open cluster, just 1 million years old. The nebula is between 30 and 34 light-years in size. Its total mass is estimated at around 800 solar masses. Its billowing clouds on the celestial vault suggest that it is made up of huge quantities of gas. And yet, on the contrary, despite its vast expanse, the nebula's mass remains relatively modest. It's one of the most prolific star nurseries in the Milky Way. Stars form here at a very high rate. The star formation phase currently underway in the outer regions of the nebula is generating around 1,000 stars. This young cluster is hidden from us by dust clouds, and the astronomers' observations had to be made in the infrared. A few massive stars have been spotted on the nebula's periphery. Their masses range from 5 to 20 solar masses. Messier 17 appears in the sky as a diffuse, high-contrast object. It can be seen just above the stellar condensation of Messier 24, which is clearly visible to the naked eye in Sagittarius. With binoculars, its central region is clearly visible, not far from a beautiful orange star. Within the constellation of Sobieski's Shield lies the richest open cluster known today. This is the Wild Duck Cluster, also known as Messier 11. It owes its name to the fact that through a telescope its stars appear to be arranged in a V-shape. In 1835, Admiral Smythe imagined the flight of a wild duck when he discovered this object. The cluster comprises some 3,000 members. The distance separating the stars from the center of the cluster is tens of times smaller than that usually observed in the Milky Way. Messier 11 is so rich that astronomers have hesitated whether to call it an exceptional open cluster or an ordinary globular cluster. Given the young age of its stars, between 200 and 250 million years, the status of exceptional open cluster has been retained. The size of the cluster is estimated at between 18 and 27 light-years. It lies around 22,200 light-years from the center of the Milky Way. In 2007, there were 82 variable stars in the cluster. The Wild Duck Cluster is very difficult to see with the naked eye. Through binoculars, it appears as a bright spot in the Sobieski Shield constellation. Its triangular shape distinguishes it from other clusters. A yellow-orange supergiant, the brightest star in the cluster, makes it easy to spot through a telescope. The globular cluster Messier 10, or NGC 6254, lies around 15,000 light-years from the center of the Milky Way, in the constellation of Ophiuchus. The cluster is thought to be around 11.4 billion years old. Messier 10 has a diameter of around 83 light-years. It contains a large population of blue stragglers. In the region in which they were observed, they are thought to have formed between 2 and 5 billion years ago. Although the cluster as a whole has a magnitude of 6.6, the brightest stars have a magnitude of 13. The cluster is very low in variable stars, with only 40 known to date. On the celestial vault, its size is equivalent to about 2/3 of the full moon, and its magnitude of 6.6 makes it easy to observe with binoculars. It appears as an extended spot. (14,700 light-years from the center of the Milky Way lies M12, or NGC 6218, a globular cluster in the constellation Ophiuchus. This cluster is close to the previous Messier 10. It can be found 2 degrees north and 2 degrees west of the latter. The cluster is around 12.6 billion years old. It contains around 200,000 stars, the brightest of which are magnitude 12. 13 variable stars are found in the cluster. Its apparent magnitude makes it almost visible to the naked eye, but it's easier to observe with binoculars in the right conditions. Messier 16 is an open cluster formed from a cloud of interstellar gas and dust. The cloud is also known as a stellar nursery, as it has entered a cycle of star formation through gravitational collapse. M16 is surrounded by a cloud of gas called the Eagle Nebula, listed as IC 4703. The M16 cluster is only 5.5 million years old. Its star formation process is therefore still ongoing. It contains massive, hot young stars. Its magnitude is -8.21. Cluster M16 is small, at 7 arc-minutes compared with the 30 arc-minute size of the nebula of which it is a part. Nonetheless, it remains one of the brightest clusters in existence. In the absence of light pollution, the nebula can be observed through binoculars, appearing as a diffuse spot. A dozen of the cluster's stars are also visible. Also known as M1, the Crab Nebula can be seen through binoculars or a small telescope as a lovely gray patch. It stands out against the Milky Way's stellar background in the middle of winter. Messier 1 is the remnant of a star explosion observed in 1054. In the summer of 1054, during the Qing dynasty, Chinese astronomers spotted a star in the Taurus constellation that had suddenly become brighter than Venus. It was described as a blue-red guest star. The supernova explosion was observed from July 1054 and lasted for around 2 years. From April 1056, its luminosity slowly diminished. Writings of the time state that it remained visible in broad daylight for more than 3 weeks. What astronomers saw then was a historic supernova. It was named SN 1054. The debris ejected during the explosion formed the Crab Nebula. The Crab Nebula is located in the constellation Taurus, some 6,300 light-years from Earth. Its diameter reaches 10 light-years. It is the first astronomical object associated with a supernova explosion. At the center of the nebula is a pulsar called the Crab Pulsar. It was discovered in 1967, although there were numerous reports of an atypical star in the Crab Nebula, going back more than 25 years. The Crab Pulsar radiates around 200,000 times more energy than the Sun, and rotates on itself around 30 times per second. It is the most energetic pulsar known to date. The pulsar generates the nebula's central radiation. It therefore plays a significant role in the structure of the nebula. The Crab Pulsar, also known as PSR B0531 plus 21, can be observed at optical, radio, X-ray, and gamma-ray wavelengths, as the beams it emits are directed towards the Earth during a certain part of its revolution. Its rotation is decreasing by around 36.4 nanoseconds per day, meaning that its current period will be slowed by around 1 second within 75,000 years. The lost rotational energy is converted into radiant energy, which heats up the surrounding Crab Nebula. The material at its center changes in a matter of weeks. Filaments of matter, measuring 1 light-year in diameter, move away from the pulsar at half the speed of light. They are created by an equatorial wind emitted by the pulsar. They alternately brighten and dim as they move away from the pulsar and spread throughout the main part of the nebula. The most dynamic structure, in the center, emits polar jets that shoot into the surrounding ejected matter. This creates a shock front. Its shape and position then change rapidly. The progenitor star is the primitive star that exploded in a supernova. Only white dwarfs with massive stars produce supernovas. In the case of massive stars, the star's core collapses in on itself and becomes immobilized in an iron core. What remains is a compact object that can take the form of a pulsar. The supernova explosion of a white dwarf star does not produce a pulsar. The Crab Nebula was therefore formed from a massive star. The progenitor star had a mass of between 8 and 12 solar masses. Within the constellation of the Unicorn, which lies to the east of Orion and immediately to the north of the Great Dog, one of the most beautiful objects is the Rosette Nebula, also known as NGC 2237-9. This is a zone of ionized hydrogen, at the heart of which lies an open cluster of young stars called NGC 2244. These stars help to illuminate the cloud by emitting ultraviolet rays. The Rosette Nebula is like a busy star factory. The Rosette Nebula lies around 4,700 light-years from the solar system. It was discovered in 1865 by an American astronomer named Lewis Swift. The nebula extends over 130 light-years at its widest point. Its mass is estimated at around 10,000 times that of the Sun. The Rosette Nebula is itself divided into several NGC objects. Its western part is called NGC 2237. A first emission region of the nebula is called NGC 2246. Another region is called NGC 2238, and finally, NGC 2244. which constitutes a very young open cluster of stars within the nebula. Open clusters are the most recognizable stellar systems. They are made up of a few dozen to a few thousand stars. These stars are like sisters of the same age, formed from the same cloud of interstellar gas and dust. However, their masses vary widely due to the non-homogeneity of the original nebula and the influences on their formation. Open clusters often remain linked to the clouds that formed them. As they orbit the center of the galaxy, they lose their members over hundreds of millions of years, and therefore don't retain their stars for long. Open clusters are not static in time. They physically change, and stars age and die. NGC 2244 is thought to be around 8 million years old. Ultraviolet radiation from the stars within it ionizes the nebula's hydrogen, turning it red. On clear, dark nights, the Rosette cluster can be seen by the naked eye as a small gray speck in the middle of the winter Milky Way. Through binoculars, the cluster reveals half a dozen bright stars. The Rosette Nebula surrounds the cluster in a faint, diffuse ring. It can be seen through a telescope. All it takes is a small gravitational disturbance for a cloud of gas and dust to collapse somewhere, forming hundreds of hot balls. If they reach a sufficiently high temperature, they will trigger nuclear reactions at their core and begin to glow. This is how stars are born in nebulae. These groups of stars are called open clusters. Once ignited, the young stars irradiate the nebula, making it glow. Their breath is so strong, however, that they create a vacuum all around them. This is how the stellar winds hollow out the nebula. In a few million years' time, the Rosette Nebula will be completely dispersed in the cosmos, but the cluster will still be there. The NGC 2244 cluster measures 33 light-years at its widest point. It contains several O-type stars, very hot stars, that produce powerful radiation and stellar winds. The stars characterized as the brightest are HD 46223 and HD 46150. Both are between 50 and 60 times more massive than the Sun, and between 400,000 and 450,000 times brighter than it. Still in the Unicorn constellation, NGC 2264 is a rather young open cluster, estimated to be 9 million years old. It lies around 2,080 light-years from the solar system. With a maximum size of 24.2 light-years, the cluster features a number of nebulae: emission nebulae, reflection nebulae, and dark nebulae. Among the best known is the diffuse Cone Nebula. Like other nebulae, diffuse nebulae are clouds of interstellar matter made up of gas and dust, but they are distinguished by their luminous emission. The Cone Nebula takes the shape of a triangle at the bottom of the nebula. It contains a bright star at its center, 15, Monocerotis. The latter is a quadruple star system comprising 4 bright blue-white stars. It is to this star system that the nebula owes its brilliance. Located some 31,310 light-years from the center of the Milky Way, Messier 92, also known as NGC 6341, is a globular cluster. It is located in the constellation of Hercules. Its age is estimated at around 13 billion years. Its mass is equivalent to 330,000 solar masses, and its diameter measures 109,000 light-years. It's a relatively old and rich cluster. Some 15 variable stars have been discovered within M92. Observing it from Earth is a tricky business. With binoculars, it looks like a diffuse whitish spot. A telescope is needed to distinguish it more easily in good viewing conditions. Messier 13 is a globular cluster in the constellation of Hercules, also known as the Great Hercules Cluster, or NGC 6205. One of the largest objects in the Messier catalog, it is located 28,400 light-years from the center of the Milky Way. Relative to its metallicity, its age is estimated at around 11.65 billion years. In the center of globular clusters, stars are tens of times more densely packed than the average for other galaxies. As a result, they can collide. In the 1920s, American astronomer Harlow Shapley established a classification of globular clusters from 1 to 12, ranging from the most compact to the most dispersed. M13 is classified as a 5 cluster and is one of the more compact ones, grouping almost 100,000 stars in a 145 light-year sphere. More than 100,000 stars are housed in the Great Hercules Cluster. In the center, the density is 100 times greater than in the regions surrounding the solar system. When the stars collide, they create a massive young star called a blue straggler. The brightest star is a variable red giant with a magnitude of 11.95. To date, 64 variable stars have been discovered in the Large Hercules Cluster. Messier 13 is at the limit of visibility to the naked eye. It is, however, very easy to observe with binoculars. It resembles a blurred star surrounded by 2 stars of not quite the same hue. Through telescopes, the vast, rich cluster is magnificent to observe. We've reached the region furthest from the galactic center. Messier 80, also known as NGC 6093, is a globular cluster found in the Scorpio constellation. It lies almost 33,000 light-years from the solar system. Of the 147 reference globular clusters in the Milky Way, M80 is one of the densest. It is mainly composed of older stars, with an average age of around 13 billion years. These hundreds of thousands of stars are held together by gravity. At the heart of the cluster are an impressive number of blue stragglers. Blue stragglers are stars that shelter in clusters of old stars and appear young. The star's youthful appearance is explained by the fact that a star attracts matter from another giant companion star, which is then gradually transformed into a white dwarf. Blue stragglers can be compared to vampire stars. This shows that stellar collisions and mergers are taking place in the core of M80. In 1860, a star suddenly became very luminous, increasing its brightness from magnitude 7.5 to magnitude 6.8. This brightness lasted a few days, after which the star returned to its original brightness. This was the nova T Scorpii. Also known as Shala, Lambda Scorpii is located in the constellation Scorpio. It is a blue supergiant and one of the brightest stars in the Milky Way. Located around 13,000 light-years from the center of the Milky Way, M14, also known as NGC 6402, is a globular cluster. It has a span of around 100 light-years. It contains 150,000 stars. The 25 brightest stars in the cluster have an apparent magnitude of 15.44, and the brightest star has a magnitude of 14. M14 is a relatively old, metal-rich cluster. Because of its distance from us, it is difficult to observe as a star, and has a milky, galaxy-like appearance. Palomar 1 is a globular cluster that was George Abel's first discovery at Caltech's Palomar Mountain Observatory. Although not a dwarf galaxy, it has the same evolutionary history as the Sagittarius dwarf galaxy. Located in the Cassiopeia constellation, Rho de Cassiope is a yellow hypergiant star at a distance of 3,420 light-years from Earth. It is one of only 12 known hypergiant stars in the Milky Way, making it an extremely rare object. Its diameter is 450 times greater than that of the Sun, or around 360 million kilometers, or 225 million miles. It also shines 1 million times brighter than our star, and regular ejections of matter make it even brighter. It's one of the few stars that can be seen without the aid of a telescope, even though it's a long way from us. Rho de Cassiope has a magnitude of 4.5 and can be seen with the naked eye in clear dark skies not far from the other bright star, Beta de Cassiope. The Milky Way is our galaxy. By studying its structure, composition, and evolution, we can better understand the history and origins of our own solar system and our place in the universe. Knowledge of the Milky Way can also help us to assess the likelihood of the existence of life elsewhere. By studying the conditions necessary for the emergence of life on Earth, and by searching for potentially habitable planets in the Milky Way, we can better estimate the frequency of the appearance of life in the universe. Our knowledge of the galaxy is limited by distance and the current technological capacity to observe celestial objects further out in the cosmos. Other unknown cosmic structures or phenomena exist beyond what we currently observe. Our solar system is only a tiny part of the galaxy. Beyond the Milky Way lies a vast universe filled with trillions of other galaxies. The observable universe contains an estimated 100 billion galaxies. Each galaxy is a collection of stars, gas, dust, and possibly planetary systems similar to our own solar system. Our journey ends here at the edge of the Milky Way, but there's still a long way to go across the cosmos.